to the smart manufacturing section. We're really glad to have you today. I think we all know there's probably no company here that's not going through some sort of a digital transformation process, and part of that is to make sure that you take a smart manufacturing approach. And some of the things you're going to hear from our four speakers here today, and if we're talking a little bit fast, it's because certainly it's a presentation-filled session. But we want to talk about things of how some of the companies that the speakers are either represent or were involved in the cases. How did they progress in the digital manufacturing journey, and what did they do as far as adopting the latest technologies and navigating not only the technical challenges but also the cultural challenges. And I think the bottom line is that if you don't have a smart manufacturing or a digital transformation plan or journey already underway, it's certainly going to put you at a severe competitive disadvantage. And so let's see here. Now it's going. So I think these are some of the daily challenges that all companies across all industries have. Certainly your processes are only getting more complex, especially with all the different technology that needs to be applied. You got challenges from government regulations. You have horrific supply chain challenges in many cases with inflationary issues, and how do you do better to manage costs, and how can you be agile and responsive in this day when it's very, very difficult to certainly know what kind of supply, raw material or supply chain issues you're going to have, what you're going to be able to manufacture, how you're going to be able to meet customer demand. So really the only way to do that is really to embrace these digital technologies and be able to implement them throughout the organization. And what are some of these digital technologies? I mean, this can range from projects from digital twins, augmented reality, virtual reality, predictive prescriptive analytics, artificial intelligence and machine learning, and doing things to be able to simulate processes before they're actually deployed. But the thing is this: to do smart manufacturing, it's a very, very scalable process. You don't have to adopt all the technology, the latest technologies at once. You may take a low-hanging fruit strategy where you actually go after the processes that require, let's say, the most attention, because maybe you have the biggest issues with unscheduled downtime, for example. But some of the things that are really critical here, some of the benefits of smart manufacturing technologies, along with the technology benefits, are the fact it helps you actually attract a new workforce. That's something people who are, let's say, can leverage some of the tools that they're using in their day-to-day life as part of their job. It really has helped with the whole collaboration, which we've all certainly experienced with the pandemic, and people working from multiple locations, and how do you help them collaborate better from multiple places. And one of the things that's also critical is with people having an endless amount of data and maybe not enough meaningful information, is to convert all that data and reduce some of that complexity to be able to do a better job and have it increase real-time visibility and really create what we like to call as a single version of the truth with all this data. But the thing is that with the workforce issue, certainly starting in March 2020, when factories started locking down, and even as recently as what was going on in China with the last shutdowns, companies really cannot be dependent on having employees that have to be based in the plant to be able to continue their production if they want to maintain their sustainability and they develop a certain level of operational resilience. So smart manufacturing technologies really now makes the worker location virtually independent of what it takes to establish a lot of these processes. And at the same time, what it does is it also provides you the tools to do a better job to see what's coming, to be able to know what's going on and get better supply chain visibility, supply chain flexibility, the ability to maybe change suppliers, and if you're able to procure a different raw material or a different component, to even now be able to change the design of the product, change the 61131 code in the PLCs or packs on the factory floor to account for the new raw material. So it really is critical in days where the supply chain is so vulnerable and where it's so difficult to manufacture finished goods, to be able to have these tools to do a better job of managing the whole supply chain issues that all of us are certainly facing. So what we're going to do is we're going to have 4 case studies of companies that have applied smart manufacturing technologies and how they have some of the positive results they've had as a result of doing that. But we also want to certainly talk about, hurdles and kind of take a Monday morning quarterback approach to the fact of how would they have done it differently. And hopefully all of you will walk away with some great tips. And the first speaker I'm going to introduce is Phil D'Antonio from Nissan, and he's going to come up here and present a Nissan case. So, Phil, come on up.
All right. Well, good afternoon, everybody. Thanks for having me today, Craig. Thanks for the invitation and the introduction. A little bit about me. So I've been in the auto industry in ITIS for about 30 years. 24 of those years tied very close to manufacturing. Today, my responsibility is quite broad and support many different business groups within Nissan under ITIS. So if you take a look at the value chain for an auto company, starts R&D, so that's my team, supply chain, manufacturing, skip over, which I don't understand, all the way to the warranty piece. So I take care of warranty, that business team, and then do the back office function. So finance, purchasing, HR, take care of tax, legal, customs, all that back office piece. And then the last thing on my list, if I didn't have enough to deal with, is the region CIO office, which takes care of vendor management and PMO. So a lot to think about. I don't really sleep that well, especially after listening to several of these presentations here over the last couple of days are on cybersecurity. So I thought we were focused, but I'm not sure focused enough. But again, so thanks for having me today, and I'm going to share the Nissan smart manufacturing journey. So if we take a look, we're going to try to bookend this, and the front sort of show what Nissan's ambition is to see what's ahead of us. And then at the end, I'll share some internal KPIs and what some external folks are saying about Nissan to try to show that I think we're doing the right thing. I think we have smart manufacturing implemented very well, and it continues to support our business around providing great quality vehicles to our customers. So in late November, Nissan unveiled something called Nissan Ambition 2030, which is our long-term vision for empowering mobility. As a pioneer in electric vehicles, Nissan Ambition 2030 places electrification at the core of the company's long-term strategy. On the screen, you see three new concept vehicles: Max Out, Surf Out, Hang Out, which again, very inspiring vehicles and exciting to see. So why do I bring this up? With key smart manufacturing principles we've applied over the last many years, we're in really good shape for tomorrow's challenges in manufacturing at Nissan. As part of Ambition 2030, Nissan plans to invest $19 billion, by FY26. I thought it was a good idea to have animation before I got here. So, part of this, so the $19 billion, 23 new electrified models by 2030. And in February, so again, we launched this big ambition in November. In February, our COO comes to the U.S. and announces that we're going to build 2 new electric vehicle models in our Canton, Mississippi facility by 2025. So again, thank God we got the foundation in place through smart manufacturing and processes and so forth that we'll be able to certainly meet that challenge here in the U.S. So now I want to transition sort of into the meat of the presentation and to convey some of the complexities we have to deal with in manufacturing and also how we've applied some of the principles. So just a little bit about Nissan U.S. manufacturing. So we got 2 vehicle assembly plants and 1 powertrain facility in the U.S. Our plant in Smyrna, Tennessee is capable of producing 645,000 vehicles per year, and it builds, this is, I mean, again, the volume's impressive, but we build 6 different vehicles on 2 lines. And then in Canton, Mississippi, we produce 450,000 vehicles with 3 vehicles on 2 lines. And the powertrain facility in Decker, Tennessee, has capability to produce 1.4 million engines, and including e-motor. So if we go into a little bit about what does that mean on 2 lines? So let's talk about a little bit about the complexity here. So each plant, when we talk about Smyrna and Canton, again, each of them has a stamping plant, each has a fascia paint plant, and each has an injection molding plant. But when we talk about 2 lines, that means 2 body shops, 2 vehicle paint plants, and 2 trim and chassis facilities. Each line builds multiple vehicles, as I said earlier, and in many cases, different platforms on the same line. So just to give you an example, we might build a truck and an SUV on the same line. We might build a D platform, which is Maxima and Altima, and the Leaf on the same line. And again, we'll talk a little bit about what's that mean and why is that complex here in just a little bit. So as customer demand changes, again, with smart manufacturing principles, we're also able to quickly adjust and need, again, and you see on here, again, we've moved vehicles between lines, and we've also moved them between plants. Very quickly and regularly, we'll do that to adjust based on the customer demand. At the same time, while we're managing all this complexity, the Smyrna plant was also recognized as the highest volume plant in North America in 2014, building 645,000 vehicles. So now we have multiple platform vehicles running on single lines. We're introducing vehicles, moving vehicles across the line in plants. If that wasn't challenging enough or reason enough to implement smart manufacturing principles, so now throw in the rapid increasing vehicle build complexity with an infinite number of build options and combinations. So the tagline here is really, states necessity is the mother invention, or it could really say do or die. So I mean, again, we have to go in advance. We have to go ahead and implement efficiencies, improvements for our business customers. So I'm going to focus in now on Smyrna, so to review some of the specific drivers. So Smyrna was expanded to 5 varying platform vehicles built on 2 lines. We were producing sedans, SUVs, and trucks on these 2 lines. A few years later, the Nissan Leaf came into play, and we launched that on the same line as the Maxima and Altima. So just a couple of things. Why does that matter? So just very easily, if you take a look at an Altima Maxima, it might be this big. Well, Leaf is this big, so different platform vehicles. So you start thinking about, well, how do I convey that from paint to trim? Well, you have to worry about how I pick the car up, how I set the car down. You may have movable details on the carriers. You may have set different pins you need to move around to be able to locate, set that vehicle. So that throws in all kinds of complexity in your controls, in your MES, and so forth to manage all that. And now you start thinking, okay, I start with Altima and Maxima on the same line. You start bringing all those parts to line side for the folks to build the vehicle, assemble the vehicle. Well, now you're already cramming all these parts into each pitch. Now you go cram in the EV parts. They're not going to fit. So now you start pushing parts away from line side. So now you have to have systems to send data to different locations. You have to have different delivery mechanisms to go to the line side, and all throws in all other kinds of goof proofing. And then if you're an industrial engineer, or process engineer, now you're going, how do I manage to the most efficient to make sure that I don't have this person, the technician putting the parts on the car, only 50% occupied, which then drives new systems, new simulations. If we did this mix, did that mix, what's it look like, and how do I plan this work out? So all that adds a huge amount of complexity to our team, to the business to manage, and again, which drove us to ensure that we had smart manufacturing principles and systems in place for them to manage their job. And then you throw all this in there, and again, it's an ever-increasing bill of material due to just crazy amounts of new technology and convenience options driven by the market. All this is going on while we increased volume by 50%. So the challenges. So when we start, if you go back in time, we had hard-coded point solutions that were not scalable. Definitely worked for us in the simpler years, but eventually caught up with us when we were struggling just to meet just fundamental business demand. Also around the same time, we had isolated manufacturing networks creating a whole different challenge. So moving forward in time, complexity is increasing at breakneck speed. Number of models and volumes grew. Floor space vanished, as I talked about, became a premium. New types of systems, more complex systems were demanded to manage that material, and new demand to manage the complexity. During all this change and added complexity, maintenance windows began to shrink. Well, why did they shrink? Well, as the volume increases, you start running Saturdays. And then as volume continues to increase, you start running every other Sundays. So factoring all these challenges plus the high cost of downtime, we had to certainly rethink our approach. So we take a look at this neat, nice, in-a-box philosophy again. User-centric, connects machines, data, people across all plants, enabling users with a configurable self-service environment, and providing operations with a greater flexibility and scalability. Now, to be super honest, we're not that smart to come up with this and wake up with it one morning and ta-da, we have it. And I think as Craig said, I mean, this is a journey and you continue to build on it. So again, due to the increase in challenges, we fine-tune this philosophy and culture. And by the early 2000s, we were definitely hitting our stride and certainly ahead of the smart manufacturing curve. And 100% we are operating in this philosophy you see here today. But, you know, maybe surprising, I don't think the components to make this work in real life just aren't technical, technology and so forth. I mean, it really involves organization, the people, the controls, the process tooling, the network, compute storage, and applications. I mean, all of it has to be orchestrated together. And if one is lagging behind or one is pulling against or against the grain, things are gonna fall apart. So again, it's so important for the leaders, it's so important to manage and influence all these factors, because again, at the end of the day, to really keep up with it, all these different things are being implemented by different people within your organization, and you really want to get to a plug-and-play mentality. So when some new process equipment comes in or some new tooling comes in, it just plugs in, it connects your systems that you have. The data is just inherent to the way you operate your business. So if you took a look a little bit, if you walked in, took a tour of any one of our U.S. facilities, one of the three, you're going to certainly see GE Prophecy all over the place. Again, Nissan has a super strong partnership with GE, started in the early 90s, so over 30 years, when we adopted GE Prophecy Tracker. We began to standardize and make simplicity a cornerstone of many of the solutions within manufacturing, from just very simple HMIs to goof-proof stations to our initial energy management system, different monitoring type systems up to the complex MES platform that we're running today. And again, utilizing the Prophecy solution delivered across many business and capabilities with tremendously effective and efficient for us. The standard platform certainly simplified our approach, allowed us to leverage a common code base to speed up delivery across projects and initiatives. And really the familiarity with GE Prophecy across all the plants and organizations reduced training significantly, improved adoption, and improved the user experience. So transformation. So in addition to setting up the right organization, we aggressively moved to one OT network, which is something key for getting ahead of the curve. Then in the early 2000s, we implemented infrastructure as a service. And I'm not sure, somebody might call me on this, but I'm not sure the marketing guys had come up with infrastructure as a service acronym at that point. But we recognized that we had servers and just stuff everywhere sprawled out through the facility, which was a huge risk to manufacturing. So we went ahead and created a resilient, robust central infrastructure, and that we served infrastructure. If maintenance needed something, if process engineering something, we served them a virtual server and they could run their application within our hardened infrastructure. So then as complexity increased, resulting parts moving from line side to kitting areas, as mentioned, the call for more technology demand. Luckily, we had the core pieces in place, and now we focused on moving from those point solutions I talked about to really product-based solutions that would be configurable by the business. Again, this is instrumental to manage the onslaught of new demand. What we want to do is we want to do it once, have it configurable, have it very where our business could expand it. So we did one or two, we managed that, and then the business can scale it to 400, 500 stations or whatever they needed, whatever the demand was. So at this time now, if we take a look at our key resources, our technical resources on the systems team, we have an immense amount of data. We're able to move fast on newer technology, new things, new value for the business, while our business runs, configures the robust product and solutions that are in play today. So if we take a look at some just internal KPIs to sort of sort of show this is what we're getting out of the key principles, the core principles, and the different technology we have in. As far as internal looking, based on our everything we discussed, we consistently achieve an annual system uptime of 99%. Now, again, traditional IT might measure that, my infrastructure is 99%, my applications are 99%, my database is 99%. This is combining all that stuff, and we're getting above 99% uptime. I'd also challenge, again, we feel like we have class-leading flexibility, again, running 9 models across 4 lines, again, all different platforms and stuff. And again, managed an unbelievable amount of growth in connected devices out on the plant floor. So now if we take a look at some popular external reviews in Nissan, on the screen you see the latest J.D. Power Initial Quality Survey. So, and again, we're so proud that on the large car segment that Nissan Maxima won the #1 Initial Quality Award, and then on the midsize SUV, the Nissan Murano won the Gold Award. But then really most impressive at all, and the team takes great pride in this, that the Smyrna plant won the Gold Plant Award for the Americas, which again was a huge celebration for Nissan. So if we take a look, and I'll wrap up here, what's next? Again, we've taken a significant focus to elevate our conversation up at the most senior level, executive level, to make sure that we're driving the best value for Nissan and our customer. Organization transformation has been key. Over the last 18 months or so, we moved we call them systems, or the OT team. We moved them from reporting under engineering to the IT team for Nissan, again, to try to get as many synergies as we can, where we then left alone things that didn't make sense to conform to the IT way, I'll say. Data visualization analytics is huge, right? And every business and everybody's going to say it's huge. But again, we've moved our data out of the transactional databases that we talked about in this robust infrastructure. We moved them up to a staging area. Our customers, our business is able to use Tableau, do all their visualizations and so forth. And now we're taking that data now and moving it up to Snowflake, which then we're going to take and say, as we move it up to Snowflake based on business cases, it's more about making sure that we're cleansing the data. So we move Canton vehicle data and Smyrna vehicle data, that it's cleansed. We've got one data dictionary that now we can use, again, use Tableau. It can also is now connected to our big data environment, Cloudera that we have. So again, a lot of work going on in there. Cybersecurity, as I talked about in the beginning, a huge focus. Again, we've got clashing of IT and OT there. So again, it's a very big focus. And now we're taking, the last thing here is taking the blueprint that we've worked on in the U.S. We've been working with our Mexico counterparts for the last 3 years, moving that down there, and then eventually going and pushing it down to South America. So with that, thank you very much.
Hello, everybody. My name's Arlen Nipper. You can see that I'm going to be channeling Pugal today. Pugal unfortunately ended up with COVID, so I'll do the best that I can to try to get his message across. Real quickly, again, my name is Arlen Nipper. I'm the CTO with CirrusLink Solutions. I've been doing automation, SCADA, communications for 44 years now. About 23 years ago, I was very fortunate in being one of the co-inventors of MQTT and trying to apply that in a lot of these solutions that we're talking about. What I'm going to be covering today, it was kind of the synopsis of this outline, is how do we go approach small to medium manufacturers that really haven't started their digital transformation journey? How can we get them started? Well, Pugal had some contacts with the state of Indiana. And over the last 18 months, CirrusLink, Inductive Automation, Opto22, Amazon have been working with the state to put together an Industry 4.0 box that we could go to all the manufacturers and get them started. So this is kind of an overview of how we started that journey. Again, the why is that we know we need to get data. We know that we need to look at digitally executed manufacturing as much as possible, be able to offer it product as a service, And then from there, be able to maybe offer connected products, depending on what product that we're manufacturing. And it all plays back into sustainability, especially with this initiative with the state of Indiana and reducing their overall electric energy cost. Now, if we look at that, we started Industry 1, 2.0. I started probably my career 1978, so that was Industry 3.0, which led us to all the problems that we have now in Industry 4.0 because we're trying to get to all these machines that we put out in Industry 3.0. But we definitely have to get an approach and some platforms and some tools to be able to do that effectively. Now, when Pugel and I put this together, Pugel has noted that if you do digital transformation, the top performers in this sector right now, well, they spend 50% less compared to the average. They spend 20% less on production expenses, have safety, they use less energy, and they're more sustainable. VW is one of Amazon's biggest accounts. As you can see, they are literally connecting 120 factories, over 10 million machines, and being able to manage that through services that Amazon offers like AWS SiteWise, Outpost, and Greengrass services. But let's look at the rest of the industry. Let's get down below the Fortune 100. Let's go to those 8,000 manufacturers in the state of Indiana. How are we going to help them? Because right now they are actually at operational loss. They've got lack of access to their data and lack of access to modern tooling. And so I've done due diligence in the last 18 months, and it is interesting. These fantastically complex manufacturing facilities, you walk in and there's PLCs on the process. They've got smart compressor systems, but nothing is connected. So they literally have all of these sensors, but no connectivity. So how are we going to help those customers? So again, doing the due diligence, we saw that they're leaving 90 to 95%, if not 100% of their data stranded on the factory floor. And our energy initiative is to go in and start monitoring the service meter of electricity coming into the building, pick a couple of machines where we can start monitoring the three-phase power, maybe go ahead and connect those machines to see state so that we can start getting some visibility between energy usage in the line, the shift, the operator, what they're and any micro stoppages they might have along their manufacturing process. But what we do also realize is that really 100% of them had no access to unsupervised AI and machine learning, and that's how we're going to improve their efficiency going forward. So I'll skip over this. The goal of this project was to give them digital transformation tools to where after 12 months they could realize a 10 to 20% improvement in their efficiency around the democratization, visualization, and insights around their energy usage in the factory. Now, I've heard of softwares eating the world. I will say, going through Pugel's deck, I hadn't really thought about AI eating software. But that really is, and going with Pugel and his team, and I wish Pugel was here. Again, he's got 25 years experience in the automotive industry with Siemens. He's got a lot of really cool stories he could tell you. But what we're really talking about here is using unsupervised AI. Because if Volkswagen has 10 million machines, you're not going to, I agree that we've got to have the visualization and all that, but there's no way a human being can have eyeballs on all those machines, and how are we going to get insights on that? So really the goal here was to provide AI tools and to analyze the data and provide information on normal versus abnormal behavior in machines and be able to measure those KPIs so we could do root cause analysis. And this has really been an eye-opener for me as we went through with this project. So how did we do it? Well, again, we're 18, 20 months into this. We did a press release on the activities that we're going to be doing in the state of Indiana and a couple of other states. But the MVP that you see at the bottom, bullet number 1, is that we had to have a platform that would give us connectivity to all those machines out there. All of the Industry 3.0, the Allen Bradleys, the Modbus, the TCP, the BACnet IP HVAC system, up on the roof, the DMP 3.0, the IEC 61850. Okay, let's get all that data in. Then let's have some tools to build models, because the experience that I've had over the last 6 years is that if we just start pumping data into data lakes, they become data swamps, and nobody ever uses it. But if you look at disruptive technology like Amazon SiteWise, you build a model first in the cloud, right? And then you instantiate that model, and that model has measurements that then you can update in real time. And the way that we did that is we used technologies like MQTT Sparkplug to be able to build a model at the edge, and with no programming, publish that model up. Because again, we're going to all of these different manufacturers to be able to do this, and run that all on an industrial platform like an Opto22 Epic, where we could get that data up. Now, once we've got it up there, then we can start doing the visualizations and the dashboard, and as soon as that model appears, it's directly piped into Amazon's new unsupervised AI. Now, there is a 90-day window, but then that can start publishing back anomalies back into our system. So we can start looking at that. You see an anomaly, and the customer goes, yeah, we know about that. But what's interesting is when anomalies start coming back and the customer goes, oh, I didn't know when this happens, this is the result. So that's the end of the presentation. Thank you very much.
My name is Mike Higley. I'm a systems architect for SDI, and I've been in the material handling industry for 20 years. What is SDI? They're a leading logistics capital equipment manufacturer, and our primary product is Bombay unit sorters, hang sorters, tilt sorters, ways to take items that go into a box and move them around to get them to that location. We also sell one of our newest product lines is called a Joey pouch sorter, and we'll get to that in a few slides. Our steel manufacturing is located in California. Our high voltage cabinet manufacturing is in New Jersey, and in Florida here we actually have our technology center where our software and our controls engineers actually build out and test our primary software suite. Our bread and butter, though, is actually unit sorters. That generally is what gets us into the warehouse or distribution center. But we're also very comfortable actually building out an entire warehouse solution from scratch or from a grass field. Some of our customers, our majority of our customers are retail customers like JCPenney's, Nordstrom's, Lulu, but we also do work with some of the larger 3PLs like Geodis and Maersk. Majority of our customer base is in the U.S., but we actually have places worldwide. Majority of it's in the U.S., next largest sections in South America, and the rest of it are actually parts beyond. So some of the trends we're seeing in automated material handling for smart manufacturing. One of the most abrupt trends we've seen was caused by COVID. It has caused companies to reevaluate how much they actually invest in automation. Whereas automation has strictly been seen in the past as ways to reduce labor or handle growth, it's now also seen as a key resource to actually mitigate risk. Another changing trend is around how we go about actually doing that implementation. For example, does your solution adapt well to the changing landscape? In the past, when we've developed unit sorters, we build them to do one specific thing very well. In most cases, it was either this piece of capital equipment was built for e-com, does e-com-based orders, or this piece of capital equipment was built to handle our retail sortation to our stores. Now, we're being challenged to actually use the exact same equipment to do both. And also, one of the challenges with the buying patterns that have changed for our customers is returns, where returns are actually up 20 to 30%, and yet most distribution centers today still process 100% of the returns by hand, no automation at all. So then we throw returns into the same mix. So today, customers are asking us to quote and build out solutions that do everything under the sun. I wanted to do e-com. I then wanted to do returns. I also wanted to do retail and off hours. Another trend we're seeing in our customers is us asking for more analytical data actually provided by these machines. So just dropping the machine on the floor isn't sufficient anymore, and having it do every possible combination of sortation. We also want to be able to pull analytics off of it. What's the uptime on the machine? What's the cycle rate of every single piece of device and I/O off of it? They're taking that and they're pushing it up into the cloud to start running AI analytics against it, and it provides proactive excessive wear metrics, and they're able to proactively actually start providing maintenance instead of dealing with it after it breaks or just sticking to a more rigid PMing plan. We're also starting to see that we're able to do predictive trending in performance to actually mitigate performance spikes. So when new increases in like e-com demand come down the pipe, then the machine's not properly staffed with labor, we begin to see that the warehouse ends up becoming a backlog. Predicting those demand spikes and then proactively getting labor ahead of there allows them to match the demand in lockstep. But without the data coming off the low-level machines to generate that statistic, you're just reactionary. Also, an interesting note on that as well is one of the barriers we're seeing as we begin to push into grass field environments or even older ones is the IT infrastructure. They're looking for us to actually do less with more. It's going to be kind of a running theme I've seen here in this forum. But they want to see us fit everything we're going to do into one rack now. It's a warehouse. They want the smallest amount of IT infrastructure as possible. How do we reduce the learning curve for our IT infrastructure? How do we reduce the number of vendors they have to support? How do we put it in small and lesser racking? Material handling for smart manufacturing shares a lot of the same challenges that I've seen presented here at this forum with other speakers. A solution builder, I guess us as solution builders for our customers are constantly being challenged to find ways to do more with less. Commonly, we see our customers asking us to match or exceed my current rate and put it into a smaller footprint, use less labor and perform the same workloads and output, and ideally all of the above, while maintaining accuracy and data integrity and quality. The ultimate measurement is generally ends up being cost and efficiency. Traditionally, these are viewed as the same thing, but in material handling, it's not always the case. We actually see efficiency having a lot more in common with cadence, where in a warehouse facility where you end up with a lot of links in a chain that tie together one back to back with the next one, taking the overall process and actually slowing it down to generate a cadence will actually give you a better throughput and higher rates to the entire building, and they end up referring to that as efficiency. So in this case, harmony equals efficiency. Efficiency ends up equaling constant rate of the warehouse or DC as a whole. This was part of the challenge that was presented for a project we did for Dillard's. Dillard's needed an e-com solution that could handle 6,000 units an hour and needed it to fit inside of a space that was 25% the size of a normal traditional unit sorter. Our answer was a Joey sortation system. It's our newest sorter in our portfolio. And what makes the system unique is that we're actually able to put it above all the existing equipment in the building. So once you've run out of floor space, where do you go next? In our case, we go up. Not only is this system actually able to handle sortation that needs to handle their needs, and be able to support a huge variety of product lines. So these pouches, we could put everything in it from lip balm to a box with boots in it, or even create eyelets where we can do hanging garment, all with the exact same platform. And in addition to just sorting them, with it being up in the air, we can actually use it to handle our storage as well, kind of like an auto storage and retrieval system, and sortation merged into one. The downside, though, is that this system ended up creating some unique new challenges. With it having over 138 Cognex cameras, and with the system transferring pouches between these cameras at about 3 pouches a second, we end up with 800 barcode scans a minute. And that's just the destination requests. Once we add in divert, confirm states, statistics generated across the entire machine, changes states of all the individual devices, we actually end up with a system that's generating about 4,000 megs worth of data a second. So when we start looking into like storage solutions that can actually handle a database that's generating really 4 gigs of data a second, you have a brand new challenge on the table that most warehouses are very unaccustomed to having to deal with. So on top of that, we can't afford to have downtime. We need redundancy. So how do you bake redundancy, and in our case, redundancy at a fault-tolerant level with a system that can actually handle a 4 gig per second write rate forever? Because when these systems turn on, you push the gas pedal to the floor and you hold it there for decades. In addition to this, we actually made a business decision to try to become a bit more agile when it starts talking about smart manufacturing. How do you do more with less? How do you allow your system to be more adaptive? Customers don't want to hear that I've got a lot of customization, so it's going to take longer. They want to hear, we can do customization, and we can do it and still hit our normal delivery times and still have it fold within the same portfolio of our baseline. To facilitate this, we actually took our PLCs that run this equipment and we normalized them down as much as absolutely possible. And we took a lot of our business rules, a lot of our decision-making logic that historically would live in a PLC, and we moved all of it into SQL, into a database. That just take this existing problem and compounded it even more. But what we got out of it as a return was a system that was incredibly flexible. If you needed to add new directional logic that needed to piggyback off of new parameters we've never used before, we simply added it as another criteria into an existing data structure model. We didn't actually have to go touch the PLC or teach it how to handle these new inputs. That was simply an abstract object that passed it up. But again, now we're putting more and more burden onto the compute module. So fortunately for us, we'd already been working with Stratus to handle our redundancies, handle our redundancy levels actually at a fault-tolerant level, and I've been doing it for several years. The FT server was actually able to scale up to the I/O needs that we ended up incurring with this solution without increasing complexity, without adding risk, and just kind of doing it right out of the gate. And although with that in mind, our customer actually did come back and ask us to try to see if we could take the same solution we were providing by Stratus and use their existing infrastructure, because hey, Mike, we've already got a 3-tiered architecture. We're just going to spin you up a VM and throw your database on that. It should be fine. And what we found is that in both 3-tiered architectures and hyper-converged solutions, that when you start talking about like 4 gigs a second actual write rate, that they can't keep up. It's normally the bottleneck ends up being the network. And when you evaluate what does it take to actually scale that network up enough to be able to hit those numbers, it's not cost effective. It ends up sometimes costing more than the actual capital equipment we're selling. In this case, though, we now have a fault-tolerant solution that cleanly scales and actually fits within the normal budget we see needed for these type of deliverables. Previously, I talked about trending patterns we see in automated warehousing with the reduction of IT. Part of that too is we're actually seeing where we're going into existing customers that we're upgrading, and we're able to pull out 3-tiered architecture, put in a Stratus box, actually reduce our amount of rack space we're reducing in half, and get rid of 3 or 4 different vendors with a single one. And in doing so, we actually reduce the how large the area is we have to support with our support contracts, and the number of vendors our customers have to manage as well from an IT standpoint. Again, both of those are pushes that we're trying to meet that expectation from our customers. One of the things that we also found is very beneficial as a company that's heavily reliant on uptime. Having a system that's actually smart enough to proactively identify hardware exceptions due to thresholds. So when hardware begins to slightly deviate from what's considered normal, it can be identified and proactively replaced. And I guess proactiveness is not something we've seen in a lot of the other hardware manufacturers, and yet it's something that's served us incredibly well in an environment that has to run this type of complex equipment for, and a lot of our customers actually run 24/7. Their only service window is a Sunday, and that's only if everything else comes perfect. Whereas if they get a large hit in e-com, oh, that Sunday's gone. So you don't have a service window anymore. Being able to proactively handle that hardware and take it out before it's hit that critical level is served us very well. Also, a lot of our machines, their primary interface with our customers is an HMI. Most of our HMIs are pulled over the OPC protocol, and we've had other speakers talk about OPC UA. And we use that for our main front end. Most of our customers, that's their single pane of glass that interacts with our capital equipment. We are now actually able to take the server health status and indicators and tie that directly into the same HMI our customers are seeing, getting us closer to a single pane of glass for an entire piece of capital equipment. These are some of the key results from our business that were directly attributed to the combination of both moving our PLC code to our database and by using Stratus to overcome the challenges that interaction caused. This is how our business has evolved to meet our customers' changing demands. Again, how do we handle that digital transformation and some of the challenges that come along with it. Our on-site commissioning time has actually been reduced under 2 weeks. Historically, it's been closer to 4. And as a business, we were pushing to see how do we move that on-site commissioning time down. With having a consistent hardware platform now, and being able to build the stuff out in-house and have a consistent deliverable that doesn't change from time to time, whereas some of our previous vendors that provided the same type of clientele, the hardware was constantly changing. We couldn't go 4 years with the exact same type of deliverable. It would change. And then we'd find out what those changes are when we're trying to deal with, oh, this has got a new hardware in it. Oh, it's got a new driver. That driver doesn't support such and such. And now we're all standing around waiting for a way to try to get our vendor to build a new driver while we're in the middle of actually commissioning a deliverable. Reduce service interruptions via fault-tolerant redundancy level. This has directly led to actually just less support calls. If the system doesn't fail and it doesn't go down, we don't get calls in the middle of the night with a customer going, we've got a 9 a.m. fire, put somebody on a plane. And again, as a side effect of that, by actually reducing our IT vendor pool, we've actually reduced the complexity that we're seeing in the support tickets we still do deal with today. Whereas, again, one of our challenges and push was, okay, when we do have a support call, how do we get the complexity down? How do we get our support calls not only to be less, but to become less complex? Downtime at a distribution center can cost a retailer as much as $1 million a day. And Stratus platform is one of the ways we actually help prevent that. SDI measures Stratus not just by the value of risk avoidance, but by the relationship and credibility that comes with delivering a bulletproof solution that runs for decades.
I'm Ted Connell. I'm with Blue Skies AI, and I want to tell you a story about the digital transformation journey that we took on with Johnson & Johnson and Intel. So a little bit of the background. I used to be with Intel, and I've been working with a lot of people out here over the years between IBM and Intel. And Johnson & Johnson had some problems. Like everybody else has been talking about, through this digital transformation, they had some problems, but they had a quality problem. They were using manual inspection for their products. And as you all well know, human beings cannot focus 100% of the time. Why did the Steelers make that trade? Oh, I was supposed to be watching this. We can't focus. We just don't do it. At best, human beings can get 98%, but that's when they're really trying. And the third shift doesn't really try, as you well know. So what do? We had to solve this problem. So we knew that AI had the potential to solve this problem. So the hypothesis was we can reduce human inspection with AI at less cost and far greater accuracy. So we put a team together and said, let's go make this happen. So I'm going to take a pause and do a call out to my client, J&J. I think they are a benchmark in digital transformation. They have a corporate-wide team. Before the announcement of the divestiture, it had all 4 business units in it, so everywhere from pharmaceutical to consumer. It still does, by the way. They put it on the executive level. There's a senior vice president reporting who runs it. It's reporting to the board of directors, so there's visibility and there's significant funding behind it. They have a process. It's an agile process, so they have a process to run. They empower local plants, so you have a corporate-wide feature empowering local plants to run projects. And then once you have projects that are successful, they promote them across the company. They don't force people to adopt them. It's a pull methodology, but they go out and promote them. So factories have the choice of, do I want to include this new success or not? But if any of you guys have ever worked at a factory, the one thing that the factory manager is most interested in is producing stuff at the right cost. And if other factories are producing more at lower cost, they're probably going to adopt that new technology. And another thing, and this is how I got involved with this, is this digital transformation team benchmark his other company. So I was leading the IoT go-to-market for Intel in the industrial sector, and I took Johnson & Johnson to our Intel fab and let them benchmark the Intel fab. One thing about an Intel fab, we talked about that in the morning with Jeff talking about Intel was forced to go on this journey 20 years ago. The new generation of Intel chips, the wire and the electronics coming out, if you think about the wire, it's 10 atoms in diameter. The wire is 10 atoms in diameter. So manufacturing at the atomic level forced Intel to go through this process, and a lot of the problems you guys are having today, Intel solved 20 years ago, and they'll partner and talk to you about it. So I would highly suggest everybody out there, to call out to Intel also. They're willing to partner with people and to benchmark, and I would highly suggest doing that. Because it shows you the art of the possible. When you're walking through a lights-out manufacturing facility or doing a window tour, you see this can really happen. This is 100% automation. The remote operating center, where the control for the factory is in a building next door to the factory, and you're wearing flip-flops. You're not wearing the gowns, and you don't have to wear masks and all this uncomfortable, really hot material suits. You wear shorts and flip-flops, and that's what they wear. So it's much better for the people, and it's much better for the business. So on the local teams, they empower the local guys, because the local guys know what the problems are. They've been working this their whole lives. I started as a process engineer. I've worked with people doing visual inspection. It's a horrible job because the person knows they can't do it, because they're always missing defects. And when they find a defect, they got to go tell someone who made the defects, hey, you made a defect. It's a horrible job. And we've been talking about we don't have enough workers in the world, right? We don't have enough industrial workers. You're paying people to do non-value-added work if they're doing inspection. You have a trained person on your staff not adding value. That's not cool. You can reassign that person to a value-added job immediately. That's worth doing this just by itself. So the local peoples know what the problems are, and they partner with the corporate team to get the assets and to get the technologies they need to solve their local problems. And then they know how to scale them because they're in their own factory. So, as I said, the background of the plan, the project, was to replace manual inspection with AA. If you guys sell product in Japan, you realize it's probably the most difficult quality country for the expectations and the level that they require in quality. So what happened is this plant, who's producing product, not all the product that they produce are produced in their plant. They might be packaging something that's produced in Puerto Rico or in Europe or somewhere else. So they import product and then they package it. And they had a big problem with inspecting. They had lots of people doing inspection. It wasn't working. They looked at doing visual inspection, machine learning, but the Windows-based, the rules-based, Cognites-based systems were just too expensive for what they were doing. There was just not the margin in there to afford to do that kind of work. So as a result, they had manual inspection, and they were stuck with it. So we teamed up and we solved the problem. So we partnered with Intel and Blue Skies, and we proved out in a minimal viable product that we can inspect over 99.9%. The only reason we only have 3 nines is the design of experiment. It actually came out 100%, but being an engineer, I won't say that if I don't have enough data to really claim that. And now we're qualifying across J&J. So we solved the problem. The local engineering team, and this is part of the promotion. What the corporate team promotes across the company, but they also encourage the local teams to get involved with the IISE and other industry groups to go out and market the success they had. So this project was just presented at the annual event a couple weeks ago. It was one of the 10 finalists in the world. So Morikawa-san, our partner in Japan, led the team. He built this project. It's his project. He owns this project. Corporate supported him. Corporate introduced me to him. He told corporate, I have a problem with visual inspection. Corporate said, hey, AI, let's try this. So that's how that works. Corporate empowers the local people, and then the local people, this guy's psyched because he's going to get promoted. He's now out there talking in Seattle at an event. He's got some really cool project he's running, and he's got corporate visibility across J&J at the senior vice president level. So that's the benchmark. That's the standard of how you get out there and make change. Because ultimately, we talked about this for the last 3 days. Ultimately, change has nothing to do with technology. It has everything to do with culture. Because technology, yeah, it changes, but it's the people. You got to change the people. And empowering the people, empowering the local, creating a corporate group to empower the local has been working in this case. So I know we've been running a little bit over. That's the presentation that I have. Why AI now? I was at Ford at their Advanced Manufacturing Center, and I was talking to the guy who runs it. This is 3D printing, autonomous driving, all the fun stuff, machine vision. And they were asking the question, do I buy a lot of hardware today because Google's building a TensorFlow? What's a tensor chip? Do I spend money now? Because I look at these roadmaps, and Intel's roadmap, they got a huge vision roadmap. Why am I buying today when we can sell tomorrow? So what we came up with J&J is we sell it as a service. So we abstract all technology risk from the client. So that way J&J doesn't have to invest in a lot of hardware. We run on a VM, we can run on the cloud, your cloud, whichever one you want. We can run in your data center, or we could run on an edge industrial PC. It's a very transparent system. It's all on virtual machines, so we can easily move it around. Autonomous machine vision, we were kind of talking about that with the AWS. Unsupervised machine vision, unsupervised learning. This is where you just show it a couple examples. So in our case, we have an inspection tool. You show it your gold standard of inspection. It's what you train your inspectors with. This is good, this is bad. You show it to the machine, and the machine can train itself. You don't need data scientists, you don't need to program, you just need to install it. One of the key requirements of this project is we have to scale it. And J&J has hundreds of plants all over the world, and very few of them, if any, have a data scientist. They have process engineers and they have site services, just like your plants. So that was the requirement, is we had to make this work within that environment. And another reason to do this now is, as I was saying, freeing up industrial workers. My clients are having a heck of a time finding workers. I have a client who literally cannot staff a third shift. Athens, Georgia, cannot staff the third shift. They have demand, they just can't build. This gives you a way to get people working on, who are currently doing non-value-added work to doing value-added work. So it's got a lot of value to your company. So that's the story. That was the journey we took with Johnson & Johnson and Intel. Thank you very much.
Invite our speakers and panelists up. Wherever you want to sit. It's just we probably have more people on the stage than any session at the forum, so we just have to. We're doing a stage test right now, and hopefully it's good for 8 people. If we go down, it'll make for a good TikTok video or something like that. But first thing I want to do is I want to let, besides the 4 speakers, we also have 3 panelists, and I guess we'll call you a speaker instead of a panelist right now. But first thing I'll do is Elena Sales. Yes. Please introduce yourself and talk about how Intel was instrumental in certainly helping Ted with some of the AI as a service.
Sure. Well, first of all, I'd like to explain, I don't know that folks know, Intel has an industry sales team. I cover manufacturing, have peers that cover retail, healthcare, education, and energy. And so we work together with partners like Ted in, obviously enabling him with some Intel ingredients, working with our end customers, many of which that we are actually working with day in and day out. But now we're going deeper into our relationship to work on the OT side of the business. And so I have been hearing in every panel discussion the echo about it taking a village, and we've got ecosystem partners, but we do find that we help our end customers actually fill those gaps to accomplish digital transformation.
Great. Next, I wanted to introduce Jason Anderson from Stratus and talk about your role in helping SDI.
Sure. Hi, I'm Jason. I lead strategy and product management for Stratus. As Mike pointed out, Stratus builds mission-critical compute platforms. They run for very long periods of time and, depending on your needs, varying degrees of performance. And we helped, our business model is to really help partners like SDI all the time. They're a textbook case of how we do business. We embed our compute technology into a solution, and then it basically makes the entire solution more resilient, better operations, and more serviceable, so you can run it for a long haul.
Okay, great. And Paul Adams from GE Digital to talk about some of your role with the Nissan project.
Sure. So Paul Adams, I'm a customer engagement director with GE Digital. Nissan's a 30-plus year customer with us. When I started as a software engineer, I was working closely with Nissan on the projects that they have going on now. And now as an engagement director, we're meeting regularly with Nissan, Phil and his team, doing governance, introducing them to new products that could help them in their journey. Like he said, the North American plants are utilizing a lot of the Simplicity technology, but we've got a lot of NPI, new product development that we're doing that we're introducing to Phil as we do with other customers. But Nissan's had a big voice in our roadmap over the years, right, as we do with a lot of our customers is, hey, how do we listen there and what they're doing and how do we align to that?
Okay, great. If anybody in the audience has any questions, certainly raise your hand, and one of my colleagues, I'm sure, will come out around with a mic. But I'd say to get things kicked off, some questions, Phil, for Nissan is, how aggressive are you moving to the cloud?
From an OT standpoint, I guess, we'll look at the cloud, but again, it's really weighed on what's the latency, what's the mission criticalness of it, and what's the security piece. Is got to be, those three things have to be comfortable. We're comfortable, we'll go to the cloud. Certainly we are doing some in manufacturing or OT, but again, I think there's still a lot of room to move that direction.
Okay. And I'll ask the other speakers as far as as far as your own progress in moving to the cloud. So say, Mike, as far as are you going
So we end up with a slightly different customer basis, and majority of them actually prefer to be completely off the grid. They're going to say, this is capital equipment, we're going to put it into a dedicated area, and we're not giving it internet access. And unless they have a very good reason, it typically stays like that. Now recently, with pushing more and more for data analytics coming out of it, they're starting to approach it with the idea of, okay, we're going to open up one hole. We're going to let one single pipe come out, and we're going to try to put everything into that, and then we're going to see how much mileage that gives us, and do we use that to justify doing more.
Mm-hmm. How about Ted with some of your projects?
Yeah, thank you very much. The cloud is obviously a tremendous asset. As Phil said, there's a latency issue. It depends on where the cloud is and how far away it is and how big the pipes are between where I am and the cloud. So love the cloud. I like it more if you drop it into my factory. That way I don't have latency issues and I have less security issues, and I know that's coming. So yeah, cloud is great. Love cloud. I love virtualization. I like hypervisors. I'm a geek. Because the data is then free to move around anywhere you want.
Mm-hmm. And certainly, Alan, I'm sure you're using Azure with your projects, right?
Absolutely. No, we're Amazon, again, the site-wide service, I think, was a wake-up call when they went to something that actually understood OT data instead of us having to stitch all that data back together again and make it look like what it looked like originally. And Azure has those same capabilities coming here fairly quickly.
Okay. Anything, just seeing if there's any audience questions right now. If not, I remember, Mike, you had talked about, certainly, what have you seen as far as the adoption of robots? You had talked about that. Can you talk about some of those rates?
Sure. So what's interesting is watching different robots come into the warehouse, and in some cases, them complementing each other. We've seen robotic ASRS solutions come in and now being paired with AGVs. So, for example, our AGV robotics solution, you can come into a warehouse that's a grass field, and you simply put in racking, and then you simply keep adding robots to it to actually pick up and move those racking around. So if you need more storage, you don't necessarily have to scale your technical infrastructure. You simply scale the number of shelves you buy. But then as throughput begins to push and decide, all right, we actually do need to get more out of this, so our rate's going up, you can now begin to buy more robots. Whereas like historically, what you've seen is like such and such as a service that scales cleaner now. We're now actually seeing robotics and logistics industry kind of follow that exact same trend.
Okay, great. And we have an audience question?
Yes. Hi, my name is Jason Benito from Magna, and I have a question for Phil. You spoke a lot about your MES and OT integration. Can you comment a little bit about your IT-OT integration during that journey too?
So you mean like from an organization standpoint, where 18 months ago or so, we took the OT team, and it's part of Nissan Digital now, or IT, I think is what your question is. So yeah, some of the synergies, really what we look at is one is that we know that it's a different service SLA to manufacturing than it is maybe to supply chain or even marketing and sales. So what we did was whatever best practices, so things that we've done, if we talk about cybersecurity. So the corporate piece is we've got Carbon Black, we've got Tenable IO. We pushed that out to all the manufacturing end devices, so now we took advantage of information security at the broader corporate level to be monitoring those devices to help offset some of that, maybe that we weren't doing so well on the manufacturing side would be one example. But certain processes that work are much more nimble in manufacturing than maybe the broader IT side, we've kept the same. So again, we're being ultra flexible, we're being careful, we understand it's a different customer, but certainly taking advantage of the synergies when we see them. So one other thing is really on from what we've seen is the IT. So my boss, the CIO of North America, or I'm sorry, the Americas, there's a lot more, again, he has access to the chairman, so wherever the OT side before used to report up to an engineering team, right? So engineering has a much bigger focus than maybe IT on the plant floor. So again, this gives them a lot bigger view. We got a lot more access to, I'll say, money than what we had before.
Okay. You know, probably as a follow-up for that, and I'll probably ask the speakers to kind of define, you know, where your project's up in particular as far as where you are on the IT-OT convergence journey. And then I'd like to ask the panelists as far as where they see all their customers as far as if they had to sum up how they're progressing in their IT-OT convergence journey. So I'll start with Alan, and then we'll work our way down.
Well, specifically on this project, with most of the small to medium, there was no IT. And it was OT convergence. I would say in a broader sense, in the space that CirrusLink works with inductive automation and companies like that, we are seeing a lot better cooperation. I think the more, you know, I guess me from a selfish standpoint, it's interesting. MQTT was invented for OT, it was adopted by IT, and now we're getting it back into OT again. And it's interesting now to have conversations where IT understand PubSub, and they're starting to understand how all these can go together, and we're actually getting a lot more convergence that way.
Okay. And Paul, I'd say from your GE Digital customers.
Yeah, I mean, I think we've seen a lot of transition in the past 5 years. I think we're seeing a lot more cooperation in the manufacturers we serve, whether it's on the discrete side or on the process side. You know, there was a lot of contention before, but, you know, Phil kind of summed it up his way. There's more cooperation. They're looking together, hey, how do we work these things together and do better to do a rollout. So I'm definitely seeing an improvement there in that relationship, customers we work with.
Okay, Jason?
Yeah, sure. So we're a technology company, and we make computers, basically. So we made a big decision about 10 years ago to begin to focus on OT and kind of get to market through them. And in a lot of cases, we were adopted almost as a rogue effort by OT, right? Kind of as a way to kind of subvert the IT standards boards. And that has changed radically. I'd say it went from us being brought in rogue to this situation, which I would say we're kind of at the waning stages of, which was OT advocated for us and they had leadership in it, and IT just basically said, do you meet these standards? Okay, checkbox, you can go. And now it's more of a collaboration where, in fact, a couple of our customers who are here today are now IT customers, or they're in these blended teams, like Nissan's referring to. So it's been this kind of interesting journey for us to watch it progress, and we're really happy to see it because we think it really lends itself well to what we provide. So we're really excited to see it go down that way.
And Eleanor?
So I work with a range of customers, and depending on who we were talking about, their digital transformation either just begun or maybe they've identified 2 of 100 use cases they want to solve for. So it's been very interesting in understanding who their preferred vendors are and if they actually have those capabilities or if Intel works with them to enable the solution just right for that customer.
Okay, Mike?
So with our customers, they end up varying so wildly. I share a lot of similarities there. What we're seeing, at least from my perspective on it, is a changing dynamic where security is playing more and more of a role, and IT is effectively being forced to kind of step up and handle that. Whereas historically you would have security and networking and IT as like different departments, they're now slowly blending as one. Kind of gets back to the do more with less. And then as a side effect of that, with IT having to pick up more of those responsibilities, there's a backfill, there's a void there. And what we're seeing is OT actually fill that void, whereas historically your OT and your floor IT tech guys, their skill set's having to radically improve because the stuff they're working with is advancing so far. And even down to some, historically what we've seen for like maintenance staff that even turns wrenches on conveyors, they're now coming in to have to understand basic electronics and programming because you don't have gravity roller anymore. You have MDR. Your rollers are motors. It's got photo eyes and cards all built into integrated circuits. You now need to be able to troubleshoot that. And what's coming with that is a better understanding and knowledge to actually support the IT infrastructure. So now we have our OT, and even like we've got customers where their maintenance and their IT and OT are really all the same thing. The next tier up is really what they're starting to just call security. It's their network, their old IT, and their network security profiles.
Okay, Ted?
Yeah, it's a great question, and it's from 0 to 100. You got everything. I'll never forget, I was in Benton Harbor, Michigan at Whirlpool. We first connected their appliances to the internet, and I'm sitting at a table, and on one side of the table, there's a guy standing on a chair who's from OT, yelling at the guy who's standing on a chair at the other side of the table who's from IT. And I'm sitting in between and going, this is not going to work. And we solved that problem, and a lot of the ways we solve that problem is report them to the same person. And you put them in the same P&L, and then suddenly everybody becomes friends because they have to. That's what I've seen the most successful companies do. Intel did that about in the mid-90s because they were forced to. But I think that's a reasonably good practice. We're all doing similar things. We're all engineers or IT. The OT folks are doing IT. They are doing IT work. I mean, and as you said, security, the IT folks know security a lot better than the OT folks, because OT folks, their security was, I unplugged it, and so, yeah, there's skill sets on both that everybody needs, and if you're standing on a chair yelling at your colleague, you're probably not in the right place.
Yeah, that's for sure. We have an audience question.
How's it going? I'm Luke Broldy from Cisco Systems. And I'd be curious to get your take on, as you're seeing more connected devices, more autonomous machinery, and this data proliferation driving decisions in the business, how you're handling security and how far down into the Purdue model you're getting. Are we getting to the machine layer, or how deep do you see that as being tangible or attainable?
That sounds like a good question, probably for the full panel, and we can probably I'll start with Alan.
I would say it goes all the way down to the edge. Again, to some extent, if you look at publish and subscribe, it kind of bypasses the Purdue model because you don't have any ports open at the edge. You can go straight up. But even with the Purdue model, let's say they have a pipeline company and they've got, I've got a private VSAT network, no problem. Well, yes, it is a problem because if somebody does get into that, now everything is open under the false pretense that, we don't have to protect our other devices. So I would say at most of the projects that we're doing across oil and gas, water, wastewater, utilities, electrical, we're going all the way to the very edge for cybersecurity.
Okay. And Paul, from your perspective from GE Digital.
Yeah, I think I would agree with that. I mean, and a lot of the customers we work with, CPG, food and beverage, I mean, that, a lot of regulations there. So the security is is really paramount to what they're doing. I'm sure Phil can talk about it from the discrete automotive perspective, but just from the customers I deal with, yeah, CPG, food and beverage, the security is pretty locked down to that edge area.
And Phil?
So while they were talking, I was struggling to get my thoughts because it's such a complicated topic. And I don't know what the right answer is. Obviously, I think from the OT side, I mean, I'd say most of us are trying to catch up where we need to be. And so that goes down maybe to the first question, Craig, that you asked about, the cloud, right? So for reasons why we might not be moving faster there, it's because of the security concerns we have on the plant floor. So it's really, again, we've got the unplug mentality, right? So for years and years and years, it's wall it off. We'll protect it with the firewalls. If something ever happens on the IT side, because nothing's ever going to happen on the OT side, we'll unplug and we can run. Right? But now, again, you start thinking about the threat actors are getting much more sophisticated. They're coming after manufacturing and OT because they see it as an easy thing to get. So, and again, we got to worry about what's coming from IT over, but you also got to worry about what's walking in your door with 100 suppliers coming in with jump drives and their PCs and laptops to go do their stuff. So again, I think we're attacking it at all angles. It's just, I would just say we're in catch-up mode.
Okay, Jason?
Sure. So it is complicated. I guess what I would say, to your point specifically, you mentioned the Purdue model. And when you think about security, there's the scope of what's protected and then how you protect it. Those are kind of two separate thoughts. We have seen a big uptick in discussion and activity about the scope, meaning, how do we provide some sort of shielding and kind of reduce the threat canvas at the, let's say, layers 2 and 1 level of the Purdue model, right at the bottom. Some of that equipment is really old. Some of it, is basically connected to the network in funky ways. So really, really hard to do besides maybe putting some intermediary type of software in to basically provide some sort of shielding for it versus actually deploying it. So it's part of the scope, but it's not necessarily part of the solution. You start to see it really show up, especially with cybersecurity, in layer 3. So we do a lot of layer 3 stuff at Stratus. That's where a lot of our stuff's deployed. And we're definitely starting to see, especially as virtualization and containerization come on board, you're definitely starting to see cybersecurity controls and systems and solutions being deployed right alongside those layer 3 pieces of software into a thing. And as you get further down the road away from the Purdue model to an IoT 4 model, that's when you start to really see it all kind of blend together, much in the way of a cloud, and then that changes the framework and the scoping of the solution. So it's kind of weird. We're in this kind of funky intermediate phase where there's a lot of Band-Aids out there. We see a clear line of sight to the future that will remain complex but different. We also are beginning to build controls into our products themselves to assist with that. So that's something else we're doing. But it's complicated, but we are seeing some trends and practices beginning to emerge, which is very, very enlightening on the plant floor.
Okay, Elena?
So I'll confess I can't get that technical with regards to that, but I am experiencing with a couple of customers we're working with through our partners, security being an issue that they're trying, we'll say, batches of data and troubleshooting to feel more confident that there is no security risk in that.
So one of the many hats I wear actually is to answer that particular question to my boss and kind of set the precedences in the company. And we do a lot of our work, majority of our deliverables are PLCs. So we're sitting there, we are the edge. And assuming that we're on a secure VLAN, that's even if it's isolated, just isn't good enough today. And we're not guaranteed that's coming across the board. So we came to the table with, all right, let's assume nothing's safe. What's the best practice we can do without killing ourselves with configuration? So a couple years ago, we set forth a standard that says every single one of our PLCs that's delivered to site is going to have a hardware-based firewall in front of it. And that firewall is going to be restricted down to only the exact explicit ports it needs to function, and it will only receive data directly from the server it's pointed to. So it has one IP it accepts and only a handful of protocols. With that in mind, we've put that into practice and had a lot of success with it. And as I'm watching some of the other security presentations earlier where they mentioned, hey, we dropped this on your network, we scan it, we can identify our devices and help it. I'm like, that wouldn't work for my world. You wouldn't see any of them unless you're actually running the scanning protocol on that one server.
Okay, Ted?
Yeah, real quick, security is everything, because without it, we have nothing. I'm a big fan of hardware and software security. If the thing's connected, you need to integrate both. So I don't think we are where we need to be. I'm scared. I know a lot of smart people are working on it. I'm happy about that. But my theory is if it's connected, it's got to be secured.
Okay. Do we have any other audience questions? If not, I have one that we'll start on this end now, Ted, because especially regarding AI. And, you know, we all know that AI is promising, but what do you think's holding back large-scale deployments? And then we'll work in this direction. So now you get to have the more time to think this time.
Yeah, it's a great question. What I've seen out in the field, a lot of companies are very successful doing studies, doing small projects in the lab. But transferring it from a lab-type environment to the manufacturing environment has been incredibly difficult. When you're building, there are three things that have to happen before you implement an IoT solution in your factory. First, you have to have a set of processes so you don't screw it up and plug something in and have what happened to Peugeot. If you don't know what happened to Peugeot, Google it. They lost 2 auto factories. So you need a process. So you got to have that set up. And then you need to have the ability to take something and scale it in your factories that don't have the same resources that you have in your lab. Your lab has a data scientist, they have programmers, they have all these resources that the factory doesn't have. So you have to dumb down your product, kind of the Steve Jobs earlier this morning, make it simple so that the people in the factory can install it and get it up and running. Once we get to that point, then I think AI scales.
Okay. Good.
So in our industry, we end up doing it specifically because it's retail. Retail has a cyclical curve to it. We know we have a curve within a day, we have a curve within a week, we have a curve within a month, we have a curve within a year, and all of them affect each other. It's a compound sine wave. So one of the holy grails of the idea was, okay, can we learn that? Can we actually get enough information out of that and actually get the information from the best place possible, the actual machine, because it's reality, and then start to graph it and apply it. And then we're now taking that is actually happening, and it's pushing it slow, and we're actually tying it into marketing. So when marketing pushes a sale, when Dillard sells a brand of women's shoes, we know that these key DCs are the ones supplying it. We're getting to the point where we'll actually start front-loaded the processing because we know historically exactly what that load's going to look like that day. And AI's come back in and said, okay, this is what they pushed for the day. This is how long the sale ran. This is how much stuff we've sold. And we've got a pretty good idea. This is how hard you're going to be hit tomorrow. You need to start proactively getting your temp laborers guys coming in now.
So with regards to AI scaling, I mean, there's one thing that I can remember. I was at a site and we were putting together an algorithm, and we actually had to rely on a person that was twice retired. And so whether we like it or not, we're going to have to be in a place where we do scale, right? We're going to have to position ourselves to have folks like that with tribal knowledge to get that algorithm right, because that next millennial generation that needs to come and do that, right? They're not going to stop what they're doing. They need a manufacturer. And honestly, this particular manufacturer couldn't even recruit people to come and work in this particular plant. So having a remote plant with algorithms defined for this production to go on was very, very key. So you're right, it's difficult to scale, but times are different. And we've got to kind of prepare for that if we want to keep going.
Jason?
I think AI is a difficult concept for people to grasp. And where I've seen it ultimately work best is when there's a really well-prescribed use case for it. And those are starting to emerge now, which is great. For instance, back to the cybersecurity point, there's a lot of cybersecurity platforms now that are integrating AI into it, and they're sharing the data between different sites so they can actually automate the process of detection, isolation, and capture. So when you hear how AI is actually applied to solving the problem, like you were describing today, I think that's when people start to get it, and that's really what's going to drive it forward. Because the idea of just kind of like, I started my career in software and kind of the Java world way back when, and what I know about it is that when you pitch a concept like Java or SOA or all these other technical concepts, until somebody says, well, why do I need it? If you just sell a platform without a use case, you're not going to sell the platform. And AI's in a little bit of that trap right now, but it's emerging, it's getting there. Like Nozomi's a sponsor here, and they use AI in their cybersecurity, and it works great, right? It's a good example.
So, I mean, the only thing I guess I'll add, and I agree with both of you, that I don't see it scaling at Nissan right now. They're very much, and again, we talked about a best practice and getting ahead of the curve, was that we were able to develop product solutions and that scaled like crazy. But what's going on in that space, I see, and again, I'll exaggerate a little bit, hundreds of vendors come into the door and selling everybody about their solution is the best solution. So and again, that opens up, and I told myself I wasn't going to go there today, but I'm going to now, is that then all of a sudden, then you pick a new product, a new company you never worked with, okay, now legal's involved, their legal's involved, and you spend 6 months working on the terms and conditions of the agreement. So, and it's a point solution. So there's an awful lot of energy right now chasing this. Now, we've got AI over many different areas, but again, it's very point solutions right now, and it's like, how do we get to the point where it is scalable, we are starting to standardize on something so it can be. So, because right now it's a lot of people chasing it, and it's a lot of overhead to manage.
So when I first started, I remember we were all worried about putting Windows PCs on the plant floor. And now, with the cloud, it's interesting today that people are talking about, hey, yeah, we're excited about the cloud. If I go back 5 years, talk to a CIO of a major automotive, not Nissan, he was like, no, we're not putting data in the cloud. They're afraid of that. And now to see that adoption, it's really good to see. AI, I agree with Jason there. It's got to get that use case. It feels like it's in the early innings. I think there's a lot of value for it. And if I'm back here in 20 years talking at this panel, we'll probably be talking about AI, and it's already in there. But I think
some of those PCs running Windows XP are still on the factory floor.
Yeah.
Alan.
Yeah, I found them.
Yeah.
Actually, Ted stole my answer, so no. So after going through all, the factory tours and especially this project that we're trying to do with Amazon, I would say, the good thing is I know what I know. Bad thing is I don't know what I don't know. I'm hoping that some of Pugal's optimism of unsupervised AI will at least start these manufacturers down the path, but at least we're getting tools in front of them, tools that they can do their own visualization, things like that. Again, I've been doing this a long time. I haven't seen any huge epiphany and go, oh my God, AI, and we just realized this. But I think we've got the tools and the technology to slowly get there, but I don't think it's going to be overnight.
That's for sure. Well, please join me in giving the panelists and speakers a round of applause. I think they did a great job.